When you're working with Node.js, it's very common to include a library that ends up throwing an error without you knowing why or how it did it. In this lecture, we're going to create an example library, require it into our index.js file, and then use the debugger to help us diagnose that that library is indeed the issue. So let's go ahead and create a library that does nothing except throw an error when its init function is called. So I'm going to call touch lib / I'm going to call this example debugging problem.js. Now let's go to that library. We're going to create it. I'm going to say that this is a library that demonstrates something throwing when its init is called. We're going to set this up like any other module. So it's going to have a container for the module, var example equals an object. At the bottom, it's going to export the module exports equals example. And in the middle, we're going to create an init function. So example init equals function, and inside this is an error created intentionally. Bar is not defined, and by that I mean we're going to say that var foo equals bar. This is going to throw an error, specifically a reference error, because foo cannot be defined to bar when bar has not been defined itself. So now that this library exists, we can go ahead and include it into our index file, and we should see that an exception is thrown when this init is called. But I don't want to crowd up our actual index file with a bunch of debugging later, and so I'm going to create a new one, but I'm actually just going to copy our existing file and name it something else. So I'm going to copy index.js to index-debug.js, and then we'll start the app with index-debug instead of index. Now we have index-debug, and it's an exact copy. Let's go ahead and start the app up with node index-debug and see what happens. Nothing so far because we haven't included this library. Now let's load this library, var example debugging problem equals example debugging problem. Now let's start it up again. We still don't have any issue because we're not calling the init. Now let's actually call the init within that library. Call the init script that will throw. So we're going to call example debugging problem.init and start it up again, and boom, we have this issue. Bar is not defined and it's a reference error. But let's say that this script is a little bit more complicated. Let's just add some logic here so that we can make this script a bit more robust. Let's say that here we create foo and assign it to 1. Then we increment foo. So I'm going to call foo++. And then we square it. Foo equals foo times foo. And then we convert foo to a string. So we're going to say foo equals foo to string. And then we call the init script that will throw. So in our example, this error that's thrown is not very cryptic. It tells us exactly what's going on. But in Node.js, you might not be this lucky all the time. You might have a reference error or some other type of error that's deep within some library and you don't know why. And you're not even really sure which part of the code is throwing or which library is throwing. And so you look back at your index-debug and you're not sure which part of this logic is throwing. You just know that when you start up the application, like so, you end up with a throw. So let's go through how you would use the debugger to step through this issue. Now there's a different way to start up a Node application if you want to use the debugger, and that is with node inspect and then your entry file, so index-debug. Now we're using the inspector, which automatically attaches the debugger. But as you can see, there isn't much going on here, and there really isn't any debugging that's happening. And so we want to kill this. Now we want to add some debugging. And so I'm going to add them all over the place so that we can step through this file later on. To add a debugging breakpoint, you just call debugger. So I'm going to call it there and there. I'm going to call it above and below basically every function. And now I'm going to add some logging so that we can tell where we are in the file. When server.init, workers.init, and CLI.init get called, they're already logging out what they're doing. And so I just need to add logging here. Console.log just assigned 1 to foo. Console log just incremented foo. Just squared foo. Just converted foo to string. Just called the library. Okay, now let's start our debugger back up. Oh, and let me just get rid of this extra L there. Start it up. As you can see, it's starting up much in the same way, but now that we have debugging points worked out here, we can use some special debug commands to walk through this file. The debugger lets you use cont to continue execution, next to step to the next breakpoint, in to step in, out to step out, and pause to pause it. For this example, I'm going to use cont. So we have continued until the next debugging point, which in this case is the first debugging point that we hit. So it has stopped at 18. If we do cont again, now we're at line 20, and we can continue doing it. Now we're at line 23. Now we're at line 25. At this point, the first logs are starting to come through. I can continue stepping down. We're all the way down at line 36 now. I'm going to keep on stepping. And I stepped all the way until the error was thrown. So if I look back through my steps, I can see, well, I made it past 49, I made it past 54, but I never reached the debugger on 59. Also, I got the console logs to come out that told me that it converted foo to a string, but I never got the console logs to come out that told me that it called the library. And so remember that this would be something you'd be doing if you couldn't figure out where these errors were being thrown from. And so using debugging steps and stepping in and out in this way could let you identify exactly which part of the code is throwing. But let's use another command to dive a little bit deeper. Let's imagine that we hadn't done this console logging, or that really the only thing that we could keep track of was the value of foo as we were debugging. So let's start this up again. I'm going to start stepping through as I did before. But at this point, let's say that the only thing that can let me know where the code is at execution-wise is figuring out what the value of foo is. So I'm going to, rather than writing cont, I'm going to write REPL. Now I'm inside of a REPL inside of the debugger, and all of the values of the variables inside of my file are made available to me in this REPL. So I can simply log out foo, and it'll tell me that it is currently undefined. So let's step out of this REPL. I'm going to do Control-C and continue on with the execution. I've gone a few more steps, and now I can step back into the REPL, try to log out foo again, and it'll tell me if foo is currently set to 2. So I can know, no matter what has been logged out, which might have not come out in a timely manner, I can know that as far as the code execution goes, what the system has done so far is incremented foo, but it hasn't done the next step. So I'm going to step out again, continue on with the execution, step back into the debugger, call foo, and now it's set to a string called for. I'll know that you must have incremented it, squared it, and then converted it to a string. How is this useful? Well, it's useful in many cases because often the issues that you're debugging in Node.js are race conditions. And with race conditions, you can't just look at where the logic has gotten to in the file, like how far down in a file the process has gone, because you have multiple asynchronous calls that you're making and you really don't know what they've done so far in their own libraries, etc. And so using the REPL within the debugger can let you step into the variables that you want to analyze and figure out exactly their state at that moment, regardless of where the execution is in this file. Because remember, very rarely will you be using purely synchronous logic inside of Node.js. You'll very often have asynchronous calls all over the place. So that is how you use the debugger to walk through your code, and how you step into a REPL within the debugger in order to analyze the value of the variables set at any moment. So with that, we can move on to the next lecture.